102 degrees in Washington, D.C. on Thursday, 103 on Friday. And when that sun finally goes down, the overnight low will not drop below 80 degrees. I want you to sit with that before we go anywhere else. In a city where the average high temperature for early July is 89 degrees Fahrenheit, we are now looking at back-to-back days running 13 to 14 degrees above normal. We are looking at an event that the National Weather Service, in their own official forecast discussion released Sunday morning, explicitly called potentially historic. I have been watching this signal build in the models for over a week, waiting to see if it would hold, or if one of the major modelling systems would back off and find a cooler solution. None of them did. Every model I pulled this morning, the GFS, the European ECMWF, the North American Mesoscale, the full American Ensemble Suite, every single one of them is telling the same story. And the story is this: the heat that more than 200 million Americans have been warned about all summer long has finally arrived. It is not approaching. It is not still days away. It is here. Today is Monday, June 29th, 2026. The clock on this event started ticking yesterday when the dome locked in over the Midwest, and by the time most of the country feels the worst of it, around Thursday and Friday, it will have been building and intensifying for most of a week. I want to take you through every piece of this forecast today, and I want to do it in a way that is actually useful for your specific situation. That means the mechanism behind why this heat is as dangerous as it is, and I am going to spend real time on this because too many people hear the phrase heat dome and think it just means a few hot days. It means the day-by-day numbers, city by city, with actual heat index values rather than just forecast highs. It means the severe thunderstorm threat that is erupting right now along the dome's edges, which is not getting the attention it deserves because the heat story is so dominant in the news cycle. And it means something at the end of this video that I think is the most important context I've delivered all summer. A look at the pattern this heat dome is embedded in, what El Niño is doing to the global atmosphere, and why what comes after July 4th may be more active than this week in some ways. I am Arthur, this is Sky Space Lab. If you are new here, hit subscribe. We track severe weather, extreme heat, and long-range pattern analysis every single day. And we do not water things down or chase clicks by making things sound worse than they are. We follow the data wherever it goes. Let us get into it. One thing I want to address before we dive in, because I have seen it come up in the comments all week. People keep asking whether this heatwave was predicted by the long-range models. The answer is yes. Unambiguously yes. The GFS was showing a significant July heat dome signal as far as 2 weeks out. The European Ensemble flagged the same setup. The NOAA Climate Prediction Center's Week 2 outlooks showed elevated temperature probability across the central and eastern United States well before the event was imminent. This is not a surprise. Long-range forecasting has improved dramatically over the past decade, and this is exactly the kind of sustained, large-scale, high-pressure event that the models handle best at extended range. The uncertainty was not whether the dome would develop, but exactly how intense it would be and where the peak heat would focus. Now that we are in the event, those questions are answered. Thursday and Friday are the peak. The I-95 corridor and the Mid-Atlantic are the epicenter. The numbers are extraordinary. Let me start with the mechanism, because I genuinely believe understanding how a heat dome works changes how you read every number that follows in this forecast. A heat dome is a ridge of high pressure that builds and extends vertically through the troposphere, the layer of the atmosphere where our weather lives. This ridge can reach altitudes of 30,000 feet or more. When that ridge establishes itself over your region, the air inside it does not rise and cool the way it normally would during a summer afternoon. Instead, it sinks. Descending air compresses under its own weight, and compression generates heat. This is identical to the physics you feel when you pump up a bicycle tire. The pump gets warm because you're compressing air. The difference is that a heat dome does this at a continental scale, over tens of millions of square miles continuously, for days on end. What prevents a heat dome from breaking down? The persistence of the upper-level high-pressure pattern. As long as that ridge holds its position and maintains its amplitude, the warm air beneath it has nowhere to go. There is no release valve. No storm system can punch through the dome and mix things up. The lid stays sealed, and the heat underneath it does not just maintain itself, it intensifies, because the ground and pavement and urban surfaces absorb thermal energy each day and radiate it back upward each night, creating a feedback loop between the surface and the atmosphere above. Here is what makes this particular dome structurally different from a standard late June warm spell, and why I want you to take this week more seriously than a typical hot stretch. The Weather Prediction Centre and AccuWeather both confirmed this week that not one but two separate high-pressure systems are merging into a single structure. The first ridge developed over the southwestern United States, the second formed over the subtropical Atlantic. What we are watching this week is those two independent systems combining, converging into a single massive dome of high pressure now centered near St. Louis, Missouri. By Wednesday, July 1st, that combined dome will be positioned to influence weather from the Great Lakes all the way down to Texas and across the entire mid-Atlantic region. By Saturday, July 4th, it shifts slightly westward, but it continues to push widespread 90-degree heat from Wisconsin to the East Coast to the Gulf Coast simultaneously. AccuWeather meteorologist Tyler Roys described this merged system as acting like a rock in the atmosphere. It forces storm systems to go around it rather than through it. It limits rainfall across the east by blocking the cloud cover and precipitation that would normally interrupt heat events during the summer. And it sustains the heat underneath it for multiple consecutive days, because the dome itself is too large and too well established to be dislodged by any of the disturbances currently moving through the atmospheric circulation. The moisture angle matters here just as much as the raw temperature, and I want to explain why. Warm and humid air masses from the Gulf waters, which are already running above normal in sea surface temperature, are being transported northward by the dome's clockwise circulation. That moisture gets trapped under the cap along with everything else. Dew points across the Mississippi Valley, Ohio Valley, and Mid-Atlantic are running in the upper 60s to low 70s Fahrenheit. When you combine ambient temperatures in the mid-90s to low 100s with dew points in the upper 60s and low 70s, the heat index, the real feels-like temperature, diverges dramatically from what the thermometer reads. A 100-degree air temperature reading with a dew point of 72 degrees does not feel like 100 degrees. It feels like 112, and the critical difference between dry and humid heat is not just comfort. It is the body's ability to cool itself. Your primary cooling mechanism is evaporative cooling through perspiration. When the air is already saturated with moisture, your sweat cannot evaporate efficiently. The cooling process slows, your core temperature climbs faster, heat-related illness develops faster. People who would survive a 100-degree day in Phoenix may struggle in the 95-degree humid air of Philadelphia or Washington, because the physiology of humid heat stress is fundamentally different from dry heat. This is not an abstract physiological point. It directly determines who is most at risk and how quickly conditions can become life-threatening, and it is the reason the National Weather Service's heat risk system classifies risk based on heat index values rather than raw temperatures alone. The dome is centered near St. Louis on July 1st. That positioning is critical for understanding who bears the worst of this event and for how long. Cities at or near the dome's center, Chicago, Indianapolis, Nashville, Kansas City, Memphis, St. Louis itself, are sitting underneath the maximum compression zone. They are the hottest and the longest affected. As the dome expands eastward through Wednesday and Thursday, the I-95 corridor from Washington through Baltimore, Philadelphia, and New York comes under the dome's direct influence. The Gulf Coast cities, New Orleans, Mobile, Biloxi, are in the maximum humidity loading zone, where dew points are so elevated that even relatively modest ambient temperatures produce heat index values that the National Weather Service classifies as extreme risk for anyone without access to cooling. Now let me give you the numbers, city by city. I want to be specific because your situation depends on your specific location and circumstances. Chicago, Illinois. The National Weather Service issued an extreme heat warning for the Chicago metropolitan area. The city is forecast to reach 90 degrees Fahrenheit or higher for 4 to 5 consecutive days, with highs potentially hitting 96 or 97 on the hottest days. The average high for Chicago in early July is in the mid-80s. Overnight lows may approach 80 degrees, which represents a historic anomaly for Chicago, threatening record warm overnight minimums. During a news briefing Monday morning, Chicago Mayor Brandon Johnson was joined at the podium by National Weather Service Warning Coordination meteorologist Mike Bardu, who specifically referenced the 1995 Chicago heat wave. That event killed 739 people in a single week. Bardu's core message was direct and precise. Heat is cumulative. Day by day, without the ability to recover overnight, the physiological burden on the human body does not stay flat. It compounds. By day 4 or 5 of a heat event with warm overnight temperatures, someone who felt fine on day 1 is carrying multiple days of unresolved thermal stress. Their tolerance is diminished, their risk is elevated, and they may not feel noticeably worse right up until they are in crisis. I want you to hold that number, 739 people, 1 city, 1 week, throughout everything that follows in this video. St. Louis, Missouri. This is the most extreme prolonged heat situation I'm tracking in this entire forecast. The current guidance shows 8 straight days in the 90s, with highs approaching 100 degrees on multiple days. St. Louis sits very close to the center of the merged dome. The city's average early July high is in the upper 80s. Running 8 or more degrees above that for 8 consecutive days is not a heat wave in the conversational sense of the word. It is a sustained public health event of a scale that historically strains cooling infrastructure, power distribution networks, emergency medical services, and human physiological limits simultaneously. Indianapolis, Indiana. Average early July high, 85 degrees. Forecast this week, 96 to 98. Heat index values pushing 105 on multiple days. The Weather Prediction Center confirmed Indianapolis is running 10 to 11 degrees above its seasonal average this week. Detroit, Michigan. Cleveland, Ohio. Columbus, Ohio. Cincinnati, Ohio. Pittsburgh, Pennsylvania. These Great Lakes and Ohio Valley cities are all inside the dome simultaneously. None of them have a relief valve from a passing cold front or a sea breeze. None of them will get a meaningful overnight break during the core of this event. Kansas City, Missouri. Multiple days of triple-digit heat index values this week. Nashville, Tennessee. Highs approaching 100 degrees with heat indices running between 105 and 110. Memphis, Tennessee. Little Rock, Arkansas. Birmingham, Alabama. All of these cities are under the dome's direct influence from the start of the week, through at minimum Thursday or Friday. Where are you watching from right now? I want to know. Drop your city in the comments. Tell me if you're inside the dome and how the heat is affecting your daily life. Tell me if you have air conditioning or if you're managing this without it. Because the difference between those two situations is the difference between being uncomfortable and being in genuine danger. Now let us move to the Mid-Atlantic and Northeast, because this is where I believe people need to be paying the most attention over the next 72 hours. The heat that has been locked over the Midwest since Sunday begins its eastward push through Tuesday and Wednesday. By Wednesday morning, the I-95 corridor from Washington through Baltimore, Philadelphia, and New York City is fully embedded inside this event. And the numbers for the East are, in several respects, more alarming than anything the Midwest is facing, because the combination of extreme temperatures and extreme humidity in East Coast urban environments creates conditions that can produce mass health emergencies without adequate preparation and response. Washington, D.C. The National Weather Service office covering this region issued a statement this weekend calling the coming event potentially the most significant heat wave for the D.C. area since July 2012. That event resulted in more than 30 heat-related deaths across 4 states, including 12 in Virginia alone. What is being forecast for this week meets or exceeds those conditions. Thursday forecast high, 102 degrees. Friday forecast high, 103. If both numbers verify, they break the respective daily high temperature records for each date. Overnight temperatures on multiple nights may not drop below 80 degrees. Washington, D.C. could have 3 or more consecutive days of 100-degree heat for just the 8th time in the city's recorded history. The current longest streak of 100-degree days in D.C. is 4 consecutive days, set as recently as 2024. And simultaneously, Washington is hosting massive public events for America's 250th anniversary celebration this week. The Capitol 4th concert on Friday evening on the National Mall, fireworks on Saturday, events at monuments, waterfronts, the Lincoln Memorial reflecting pool, drawing hundreds of thousands of visitors from across the country and around the world. People who planned this trip months ago, who are arriving in a city where the forecast high on Friday is 103 degrees, and the overnight low will not drop below 80. Mayor Muriel Bowser held a public safety briefing Monday morning. City officials are activating cooling resources across the district. This convergence, the largest public gathering the city has hosted in years, coinciding with the most dangerous heat event the region has seen in more than a decade, is the specific scenario I am most concerned about when I look at Friday and Saturday, Richmond, Virginia. forecast to top 100 degrees for 3 consecutive days, with each day expected to break its own daily high temperature record. The NWS office for Richmond described this as potentially approaching the city's hottest July temperatures on record. Raleigh, North Carolina. According to the AccuWeather Heatwave Severity Index, Raleigh earns the most severe classification among major cities in this event. Raleigh's official heatwave threshold is 95 degrees. The city is expected to exceed that threshold for multiple consecutive days. Overnight lows late this week could flirt with Raleigh's all-time record warm overnight low of 80 degrees. Philadelphia, Pennsylvania. Forecast to reach 100 degrees on 2 to 3 days despite average highs in the upper 80s for this time of year. AccuWeather's heat index forecast for Philadelphia on Thursday, 112 degrees. Feels like temperatures at 112 can cause heat exhaustion in an unacclimated individual within 30 to 60 minutes of moderate outdoor activity. New York City. The National Weather Service issued an extreme heat watch covering the region from Monday through Wednesday, with feels-like temperatures forecast to hit 108 degrees. Central Park has not recorded a 100-degree temperature since July 2012, 14 years ago. Thursday is the closest call in all of that time. CNN's meteorological team reported this week that New York City could tie both its daily high temperature record on Thursday and its record warm overnight low Thursday night. The city has updated over 2,000 Link NYC kiosks to display walking directions to the nearest cooling center, Newark, New Jersey. Due to the city's intense urban heat island effect, Newark is considered more likely than Manhattan to reach or exceed 100 degrees on 2 or more days this week. Boston, Massachusetts, Vermont, New Hampshire, Maine. States where a significant percentage of households do not have central air conditioning, because historically they have never needed it for summer survival. All of them are inside this event. Updated Monday morning from NBC News. 145 million Americans are now under active National Weather Service heat alerts. That is roughly 43% of the entire United States population under some form of official heat warning, advisory, or watch right now. This is not a regional heat wave, this is a national one. Something else I want to address before we get to the day-by-day timeline, because it comes up every time I forecast a major heat event. People from the southeast, from Florida, from Georgia, from Alabama and Mississippi, sometimes look at these numbers and think, we deal with heat every summer. 95 degrees in July is a normal week for us. What is the big deal? Here is the specific difference. The southeast has a broadly heat-acclimated population. Your bodies have spent weeks and months adapting to elevated temperatures and high humidity. Your cities are built with summer heat in mind. Your outdoor work schedules and daily routines are calibrated to a climate where July heat is a baseline expectation. The cities of the Midwest and Northeast are not heat-acclimated in the same way. A resident of Minneapolis or Philadelphia or Boston in late June has spent the spring in temperatures 15 to 20 degrees below what this week will bring. Their bodies have not completed the physiological adjustments, increased plasma volume, more efficient sweat response, earlier onset of perspiration, that come with sustained heat acclimatization. Their housing stock has less air conditioning penetration. Their populations include a higher proportion of people who simply do not own a functional air conditioning unit, because historically they have not needed one in July. When 102 degrees arrives in a city that typically sees 78 in early July, the mismatch between the heat and the population's adaptation to it is the source of mass health risk. And that mismatch is exactly where the danger concentrates in events like this one. Let me give you the specific day-by-day roadmap now, because I think knowing exactly how each day unfolds this week is critical for planning your response to this event. Monday, June 29th, today. The dome is fully established over the Midwest and Great Plains. Highs from Kansas City to Chicago to Indianapolis are running in the mid to upper 90s. St. Louis hits 95 today. The Gulf Coast states, Louisiana, Mississippi, Alabama, the Florida Panhandle, are already experiencing heat index values above 100 degrees. Extreme heat warnings are active across Illinois, Iowa, Kansas, Michigan, and Tennessee. More than 130 million Americans are under at least moderate heat risk classification today. Along the dome's northern edge, the first ring of fire thunderstorm clusters are beginning to organize across the northern plains. I will cover this in detail in a moment. Tuesday, July 1st. The dome strengthens and begins its eastward expansion into the Ohio Valley. Columbus, Cincinnati, Pittsburgh, all moving from uncomfortable into genuinely hazardous conditions. Heat indices across the Midwest and Ohio Valley are reaching 100 to 110 degrees today. Morning low temperatures in the upper 70s and low 80s are offering almost no recovery window for people who spent all of Monday in the heat. For anyone in the Midwest who has been in this event since Sunday, Tuesday is day 3 of cumulative heat stress. This is when the physiological arithmetic of sustained heat exposure starts to matter. The ring of fire thunderstorm clusters shift toward the Great Lakes and begin their approach toward the northeast boundary. Wednesday, July 2nd. The pivot day for the Mid-Atlantic and Northeast. The dome's eastern edge pushes hard into the region. Washington, D.C. temperatures approach or reach the upper 90s. Philadelphia climbs toward or above 100 degrees. New York City's extreme heat watch period begins. Overnight lows in urban areas along the I-95 corridor struggle to drop below 80 degrees. I want you to think carefully about what this means for someone in an apartment without air conditioning in Philadelphia or Washington. Someone who woke up Monday morning already hot, who went through Monday, could not sleep Monday night, who went through Tuesday, could not sleep Tuesday night, and who is now entering Wednesday carrying 2 days and 2 nights of accumulated thermal stress. Thursday, the hottest day, is still ahead of them. They have no recovery window remaining. Thursday, July 3rd, peak intensity for the Mid-Atlantic and Northeast. Washington, D.C. hits 102 degrees. Philadelphia reaches 100. Raleigh, 103 with a heat index of 107. Richmond, 100 degrees for the second consecutive day. New York City, 98 degrees with a heat index approaching 108. This is the day the Weather Prediction Center flagged specifically as carrying the possibility of all-time record high temperatures in multiple cities. Senior meteorologist Mark Chenard told the New York Times this weekend that Washington, D.C. will almost certainly exceed 100 on at least 1 or 2 days, and that Philadelphia and New York City are also currently forecast to go over 100. NBC News reported Monday that by July 4th, close to 100 new daily high temperature records could fall across the eastern United States. This is one of those moments in a forecast where the data is so consistent across every modelling system that I have very high confidence in the outcome. Thursday is going to be historic for the East Coast. Friday, July 4th, Independence Day, America's 250th anniversary. Washington, D.C. hits 103 degrees. The heat index in the nation's capital on Friday is forecast to reach 108 to 110 degrees. Philadelphia, heat index approaching 112. New York City, heat index of 106. Raleigh, 103 with a heat index of 107. And simultaneously, across all of these cities, hundreds of thousands of people will be standing outside for fireworks, sitting at cookouts, attending outdoor concerts and public celebrations. NWS forecaster Brian Putnam said it clearly on NPR Sunday. Just because the sun goes down does not mean it is safe. Evening temperatures on the 4th in most cities will still be in the upper 80s to low 90s, with heat indices remaining elevated well into the night. Watching fireworks at 10 p.m. in Washington or New York means standing outside in a heat index that is still dangerous. Not just uncomfortable, but dangerous. Saturday, July 5th. The dome begins its westward retreat as a front approaches the northeast from Canada. The eastern seaboard sees the first hints of relief by Saturday afternoon or evening. But the Great Plains, Midwest, and the entire southern tier of the country continue to roast well into the following week. The heat does not end after July 4th. It relocates. Let me say one more thing about overnight temperatures before I move on, because I think this single element is the most underestimated part of this event. During a typical uncomfortable stretch of summer heat, nights provide a physiological recovery window. Core body temperature drops. You sleep, you reset. You wake up on a depleted baseline, but you have some margin to work with. When overnight lows are 80 degrees or above in a dense urban environment, with pavement and brick radiating stored thermal energy upward through the night, with high humidity preventing evaporative cooling, with city architecture trapping warm air, that recovery window simply does not exist. Your body cannot reset. Every morning you wake up carrying the unresolved thermal debt of every previous day and night. By day 5 or 6, by Friday and Saturday, people who have been in this heat since Monday without access to adequate cooling are not in the same physiological state they were in on Monday morning. They are carrying accumulated damage. their heat tolerance is diminished, their risk of rapid onset heat illness is elevated, and they may feel essentially fine right up until the moment of crisis, because heat illness, unlike tornado damage or hurricane flooding, does not always announce itself with visible warning signs until it is already an emergency. This is the mechanism that produced 739 deaths in Chicago in 1 week in 1995, and this is why I am asking you to treat this as a 6-day weather emergency, not a collection of individual hot days. Now I want to spend meaningful time on the Ring of Fire severe weather pattern, because there is a major and ongoing storm threat encircling this dome that is being significantly underreported. Here is how the Ring of Fire works. When a massive, stable dome of high pressure occupies the center of a continent, the atmosphere inside the dome is too warm and too capped for thunderstorm development. The warm air aloft acts as a temperature inversion, a cap that prevents surface-based instability from releasing upward. Storm systems trying to develop under the dome cannot punch through the cap, but the instability and the moisture are still there. They have just been suppressed. They push outward. They concentrate on the dome's edges, where cooler and more unstable air from the north or west encounters the dome's warm boundary. That boundary zone has both the instability to generate storms and the moisture to sustain them, and because small atmospheric disturbances are continuously rotating around the dome's perimeter, spinning off the main circulation like sparks off a wheel, new rounds of thunderstorms keep getting triggered in these edge zones. The result is a continuous or semi-continuous arc of severe thunderstorms circling the dome, firing and refiring for as long as the dome persists. AccuWeather senior meteorologist Alex Sosnowski confirmed this week that a full Ring of Fire pattern is now active around this dome, and it is expected to fuel repeated severe thunderstorm outbreaks across large parts of the north-central and northeastern United States through the 4th of July weekend. Multiple distinct severe weather zones are identified in the current setup. The first runs along the southern high plains, from eastern Colorado through the Texas Panhandle into western Kansas, western Oklahoma, and New Mexico. This zone is active today and remains active through the week. Damaging straight-line winds and large to very large hail are the primary hazards here. Flash flooding is possible wherever storm clusters repeatedly track over the same areas. The second zone, the one I am most focused on for tornado potential, runs along the northern edge of the dome, from the Dakotas through Minnesota, Wisconsin, and into the upper peninsula of Michigan. This is an area with extraordinary atmospheric energy right now. Meteorologist Max Schuster of Max Velocity Severe Weather Center published a detailed Ring of Fire analysis Monday morning that is the most comprehensive assessment of this severe weather threat I have reviewed. The number that jumped off the page immediately, some instability values forecast across Minnesota, Wisconsin, and Iowa heading into Tuesday afternoon, are approaching 5,000 joules per kilogram of CAPE, convective available potential energy. 5,000 joules per kilogram. Let me put this in context. 2,000 joules per kilogram supports significant severe thunderstorm development. 3,000 is considered very high and can support violent storms. 4,000 is associated with extreme storm potential, the kind of environment where long-track tornadoes and baseball-size hail are possible if the wind shear environment cooperates. 5,000 joules per kilogram is a number that appears in the atmospheric analysis of the most extreme convective events in the meteorological record. The atmosphere over the upper Midwest on Tuesday is not just loaded, it is extraordinarily loaded. Monday evening, clusters of storms are developing across the northern plains and consolidating as they push toward Minnesota and Wisconsin. The primary threat tonight is damaging straight-line winds. These early clusters will likely upscale into squall lines or mesoscale convective systems, rather than maintaining the discrete supercell structure that produces the highest tornado risk. That said, any supercell that maintains its organization ahead of the main line tonight deserves close monitoring. Tuesday is the day I'm most focused on for tornado potential this week. By afternoon, a new line of thunderstorms is possible across northern Wisconsin and eastern Minnesota, with the potential for an intense cluster to develop rapidly by evening. Schuster specifically flagged the areas near Warsaw, Wisconsin, and Marquette, Michigan, as the zones he is watching most closely. The tornado potential on Tuesday comes down to a single variable that the models cannot definitively resolve until early Tuesday morning, exactly where the surface low pressure system positions itself. If it tracks far enough south into Minnesota, the combination of surface instability, directional wind shear change with height, and the presence of a sharp moisture boundary creates a configuration that supports rotating supercells with significant tornado potential. If the low stays near the Minnesota-Canada border, the main hazard remains damaging straight-line winds and very large hail, with tornado risk staying marginal. I will pull the latest GFS and European morning runs first thing Tuesday and update this picture if the guidance changes meaningfully. But Schuster said explicitly he would not rule out a significant tornado if the environment comes together correctly, and based on what the GFS ensemble mean was showing as of late Sunday night, I share that concern. Wednesday brings another round. The broad atmospheric setup that generated Tuesday's activity remains in place, and new disturbances continue their rotation around the dome's perimeter. Another cluster of thunderstorms is possible across Nebraska, South Dakota, and into the upper Great Lakes Wednesday afternoon and evening. By Thursday, storm activity shifts toward the Great Lakes and could affect Indiana, Ohio, and southern Michigan, areas that have seen relatively little organized severe weather over the past several weeks, which means populations there may be less on alert than areas with more recent experience. AccuWeather identified the 4th of July weekend stormiest zone as extending from Colorado and New Mexico eastward to Florida and northward along the Atlantic seaboard. The ring of fire shifts with the dome as the dome moves westward after the holiday, so as the heat retreats from the northeast, the storm zone follows it southwestward. Damaging winds are the primary hazard across most of the ring of fire this week. Large to very large hail is the secondary threat. Tornadoes are a conditional hazard, requiring the specific combination of surface instability, adequate directional wind shear, and storm morphology that may or may not fully materialize depending on how individual systems evolve at any given location. I am not issuing a tornado outbreak forecast for this week. What I am saying is that with 5,000 joules per kilogram of CAPE over the upper Midwest on Tuesday, the energy in this atmosphere surrounding the dome is extraordinary, and any organized severe weather outbreak this week can include a significant tornado if the right localized ingredients come together. Both threats, the extreme heat and the ring of fire severe storms, are real and active simultaneously. Managing both of them at the same time, across the same general region, is the meteorological and public safety challenge of this week. Now let me take a major step back and put this week in its larger atmospheric context, because the most important thing I can tell you about this heat dome is not the Thursday or Friday temperature numbers, it is where this event fits in the pattern of this summer and what comes next. El Nino. I need to be specific about where we are right now. The Nino 3.4 index, the primary measurement of sea surface temperature anomalies in the equatorial Pacific and the key metric for El Niño intensity, is approaching +1 on its scale as of the latest available readings. +1 puts us in the neighborhood of moderate El Niño territory. Sea surface temperatures south of Hawaii and along the South American coastline are running significantly above normal, confirming the developing pattern. Multiple long-range forecast agencies, including Climate Impact Company and Colorado State University, have flagged the potential for a strong or super El Niño to emerge by late summer and into fall 2026. Severe Weather Europe published analysis within the last 72 hours showing the atmosphere is actively beginning to respond to El Niño's large-scale forcing in ways that align closely with historical patterns observed during previous super El Niño summers. Here is what El Niño's fingerprints on this summer mean in concrete terms for the United States pattern. El Niño strengthens and displaces the Pacific jet stream. In a developing super El Niño, the subtropical branch of the jet becomes more energetic, transporting warm, moist air from the tropical Pacific into the southern tier of the United States. That moisture feeds into the Gulf waters, which are already running above normal in sea surface temperature, partly because the heat dome radiating its thermal energy downward this week is further warming the Gulf surface. El Niño also tends to support the kind of large-scale high-pressure ridge we are watching this week. Severe Weather Europe's analysis shows the July 2026 pressure pattern trending toward a high-pressure ridge over the central and eastern United States and deep into southern Canada, driving a strong, warm southerly flow, and they note this anomaly closely resembles the setup observed during previous super El Niño Julys. This is not a coincidence. El Niño is architecturally connected to the pattern we are living through right now. El Niño also increases wind shear across the Gulf Basin, the Caribbean, and the Atlantic main development region. That shear is the primary reason NOAA issued a below-normal Atlantic hurricane season forecast for 2026. But I want to state this with precision. because the phrase below normal is widely misunderstood. Below normal is a seasonal average over the entire June through November period. Within a below normal season, individual windows of reduced shear open and close as the upper level pattern evolves week to week. A tropical system that organises during one of those shear relaxation windows, when the Gulf waters are warm and the atmospheric instability is elevated, can intensify and become a significant storm regardless of what the seasonal average forecast says. Below normal does not protect any individual coastal community from any individual hurricane or tropical storm. Bloomberg published analysis this week noting that the European heatwave, which resulted in approximately 1,000 excess deaths in France alone based on preliminary official figures, is also being reinforced by a strengthening El Nino, the same large-scale forcing that is helping sustain the dome over the United States is contributing to the blocking pattern that has produced record-breaking heat from Spain to France to the United Kingdom. Two separate continental-scale heat events, both amplified by the same El Nino signal, both occurring in the same week. This is what a developing super El Nino in the atmospheric record looks like at the global scale. It is not a regional anomaly, it is a global pattern shift, and both Americans and Europeans are experiencing the consequences of it simultaneously. For what comes after July 4th, I am most focused on the NOAA Climate Prediction Center 6 to 10 day outlook, which covers the second week of July. That outlook shows above normal temperature probabilities across the entire eastern half of the country. The dome weakens and shifts westward after the holiday weekend, but the atmospheric baseline temperature remains elevated. The GFS ensemble mean I pulled this morning shows the dome rebuilding across the south-central United States by mid-July, with warm southerly flow resuming its transport of Gulf moisture northward. This is not a pattern that flips off after the 4th of July and returns to normal. It modulates, briefly relaxing in the northern tier, then rebuilding from the south. For severe weather, the second and third weeks of July are the period I'm tracking most carefully for what comes next. The Weather Network's 2026 summer forecast describes this season as featuring a more active jet stream than recent blocked-up summers, meaning more movement through the atmosphere, more disturbances rotating through the pattern, more ring of fire episodes around heat ridges. Model data for mid-July is already beginning to show repeated disturbances moving out of the Pacific Northwest into the Central Plains, interacting with Gulf moisture that El Niño's subtropical jet will continue to pump northward. That combination has historically produced major organised severe weather outbreaks. I think the second and third weeks of July may actually be more active for severe weather than this first week of July, even though the heat story this week is more dramatic. This week is primarily a heat event with a severe weather subplot. What follows it has the potential to become primarily a severe weather story. For the tropics, the mid-July pattern shift is the window I am watching most carefully. The upper-level high is expected to temporarily reposition westward during the third week of July, allowing a brief relaxation in Gulf Basin wind shear. The Gulf waters at that point will be at or near their seasonal peak warmth, further elevated by the thermal energy being added this week by the heat dome overhead. AccuWeather's July 4th weekend forecast specifically identified one zone to watch, the southern Atlantic coast and the Gulf Coast, where existing thunderstorm clusters could potentially organise into a tropical depression or tropical storm through the holiday weekend, bringing torrential rain, gusty winds, rough surf and dangerous rip currents to coastal areas. That is not a confident tropical development forecast, but the signal is present in the models, and experienced meteorologists are flagging it explicitly. I am not tracking a designated NHC disturbance right now. What I am saying is that the environmental preconditions for tropical development in the Gulf Basin during the third week of July are more favourable than at any point this summer. Warm sea surface temperatures, a potential window of reduced shear, an atmosphere primed by weeks of sustained moisture loading from El Niño's subtropical jet. I will have a full dedicated tropical update later this week as the mid-July pattern resolves in the model guidance. Let me go even further into the specifics of what the Ring of Fire means for individual communities this week, because the broad description of zones and hazards does not always translate into actionable information for someone in a specific city trying to decide how to spend their week. For the Northern Plains and Upper Midwest zone, the Monday evening storms will be the opening act. These early Monday storms are most likely to produce wind gusts in the 50 to 60 mile per hour range, with some locally stronger gusts possible where the most intense cells develop. Large hail, quarter to $half size, is possible in the stronger storms. The primary threat corridor for Monday evening is from central South Dakota through central Minnesota and into western Wisconsin. If you're in this corridor and you see a tornado warning issued, even if the storm is a fast-moving squall line, please take cover immediately. The early evening hours before storms upscale into a line are the window when a brief embedded tornado is most possible. Tuesday is the day I am allocating the most forecast uncertainty to because of that surface low position question. Here is how I want you to think about it. If you are in Minneapolis, St. Paul, Rochester, or any of the metropolitan areas of southern Minnesota and western Wisconsin, Tuesday evening is the time to have your severe weather plan active and your phone charged and receiving local alerts. The time window I am watching most closely for the highest storm intensity and potential tornado risk is between 4 p.m. and 9 p.m. Central Time on Tuesday. That is the period when daytime heating has maximized the surface instability, when the low-level jet is beginning to strengthen and add directional wind shear, and when the atmosphere is most favorable for supercell development ahead of any organizing line. For Wednesday, the storm risk shifts slightly. The corridor I am watching runs from northeastern Nebraska through central Iowa into southern Wisconsin and northern Illinois. This is the zone where I think Wednesday's most significant weather is most likely to develop. Damaging wind gusts in the 55 to 65 mile per hour range are possible. Large hail, nickel to quarter size, is the likely primary hazard. Tornadoes are possible, but I consider them a lower risk than on Tuesday. For the 4th of July itself, the severe weather concern concentrates along the Atlantic seaboard from Virginia northward and along the Gulf Coast from Louisiana eastward. Any organized cluster of thunderstorms in these zones can produce locally dangerous conditions for people who are gathered outdoors for celebrations. Lightning is always the immediate threat at any thunderstorm-related gathering. Plan ahead. Know what you will do if you hear thunder at your fireworks show. Get to a hard-sided shelter, a building or an enclosed vehicle, and stay there for 30 minutes after the last thunder. Do not shelter under trees. Do not wait to see how bad the storm looks before you move. By the time a storm looks dangerous at an outdoor gathering, it is too late to make orderly movement decisions. AccuWeather explicitly noted that thunderstorm activity tends to ramp up in the afternoon and then diminish during the evening in this kind of pattern, which is both good news and uncertain news for 4th of July evening fireworks shows. The good news is that if significant storms develop during the afternoon, they may weaken as the surface heating diminishes after sunset. The uncertain news is that in a ring of fire pattern with the kind of instability I'm describing, organized storm systems can sometimes persist or develop new cells into the evening hours if the upper-level forcing and low-level jet support continued activity. I will be updating the severe weather picture throughout the week as each day's storms become clearer in the short-range guidance. Before I close out this video, I need to return to the heat one final time. Because I think the most important thing I can say today is not a weather number. It is something simpler than that. Heat is the most dangerous weather phenomenon in the United States, not in years with catastrophic events, every year, on average, consistently, year after year. The National Weather Service confirms this in their own published statistics. Heat kills more Americans annually than tornadoes, hurricanes, and lightning combined. All three of those dramatic, visually powerful weather phenomena combined do not match what heat does to this country quietly, invisibly, every single summer. What makes this week uniquely dangerous is not just the temperatures, it is the architecture. 145 million people under active heat alerts, overnight lows above 80 degrees in the urban core cities that are most exposed, a holiday weekend placing the maximum possible number of people outdoors for extended hours during the peak intensity days of the event, a capital city hosting hundreds of thousands of anniversary visitors, while the forecast high on Friday is 103 degrees, and overnight temperatures will not drop below 80. Cities across the mid-Atlantic hosting fireworks shows, and outdoor concerts on the hottest and most humid nights this country's northeast has seen in years. And a population that will underestimate the cumulative threat because Day 1 and Day 2 of this event will not feel catastrophically different from previous hot summers. The danger compounds quietly, daily, without the dramatic warning signs that announce other hazards. By Day 5 and Day 6, by Friday and Saturday, the people who have been in this heat since Monday without access to adequate cooling will not be in the same condition they were in Monday morning. They will be carrying 5 or 6 consecutive days of unresolved thermal stress. their capacity to tolerate additional heat exposure is diminished. Their risk of sudden onset heat stroke is elevated, and they may feel fine right up until they do not. The 1995 Chicago heatwave killed 739 people in 1 week. The vast majority of those deaths happened on days 4 and 5, at night, after people assumed the danger had passed because the sun had gone down. Please act on this forecast now. Cooling centers are open in Chicago, New York, Nashville, Washington, and dozens of other cities. New York's Link NYC kiosks are directing people to the nearest cooling center within a 10-minute walk. Use them. Check on your elderly neighbors and on anyone you know who lives alone or without air conditioning. Do this today, not Thursday. Do not leave children or animals in a parked vehicle for any amount of time under any circumstances this week. Hydrate consistently and continuously, not just when you feel thirsty. Thirst arrives after your body's already behind. Know the difference between heat exhaustion, which responds to rest and fluids in a cool environment, and heat stroke, which is a medical emergency requiring immediate 911 response. Confusion, absence of sweating despite extreme heat, hot and dry skin, or loss of consciousness. Any of these is a call 911 situation. Do not wait. For everyone planning to be outdoors for the 4th of July, celebrate. It is 250 years of this country. Be there for it, and be smart about it. Know where the nearest cooling shelter is before you leave your house. Set a hydration reminder on your phone. Set a check-in plan for anyone in your group who is elderly or has a chronic health condition. Have an exit plan before the fireworks start. Have you ever been through a heat wave like this one in your area? Have you seen temperatures like these before? Drop a comment below with your city and your experience. Every region has a different baseline for heat tolerance, and those on-the-ground reports help me calibrate the forecast context I give you week to week. Tomorrow, I will be back at this desk with a complete update. How the dome is tracking against this morning's forecast, what the Ring of Fire severe weather threat is doing as Tuesday's storm potential develops across the upper Midwest, and what the latest model runs are showing for the mid-July pattern I've been building toward all video. If you're not subscribed, this is the week to do it. The forecast changes every 12 hours right now, and I want you to have the most current information before you walk out your door each morning. Hit the like button if this breakdown gave you something useful. That is genuinely how this channel reaches more people who need this information during a week like this one. I'm going to be at this desk every single day, pulling every model run, every NWS discussion, every ensemble update as it comes in. I want to add one more thing before I wrap up, and it is something I've been sitting with all morning as I've been pulling the data and building this forecast. This is a week when America turns 250 years old. Every major city in the eastern United States, Washington, New York, Philadelphia, Boston, Chicago, Nashville, is going to be hosting some form of celebration. Families are traveling. People are gathering. There is going to be joy and community and pride in enormous quantities across this country on Friday and Saturday. I genuinely believe in that. I am glad this country exists, and I am glad it is celebrating. And I am asking you to celebrate this week the way you would celebrate a sporting event in a stadium during a thunderstorm. You would not stand in the bleachers during a lightning event because you had already paid for the tickets and were excited to be there. You would go to the concourse, watch from inside, wait it out, and return when it was safe. The principle is the same this week. You can celebrate. You should celebrate. But make the smart choices. Have the plan. Know where the cooling shelter is. Know when to move someone inside. Know the signs of heat illness. And do not assume that because you feel fine at 9 p.m. on the 4th of July that everyone around you is also fine, because the effects of heat on different bodies, depending on age, health, hydration, acclimatization, and dozens of other factors, vary enormously. The person sitting next to you at the fireworks show who has been quietly in the heat all day may be much closer to a heat emergency than you are, and may not realize it themselves. Take care of each other this week. That is not a meteorological instruction. It is a human one. And it is the most important thing I can close with today. Tomorrow morning I will be back. Check back for the latest Ring of Fire severe weather update as Tuesday's storm potential becomes clearer in the morning model runs. Check back for the updated dome tracking as the event moves toward peak intensity Thursday. Check back for anything new on the mid-July pattern and the tropical window I am monitoring for the 3rd week of July. This channel exists to give you the information you need to make smart decisions during weeks like this one. Like the video if it gave you that. Subscribe if you want to stay current all summer long. I will see you tomorrow. Stay hydrated, stay cool. Do not underestimate what is outside your door this week. This is Arthur. This is Sky Space Lab. I will see you tomorrow. Let me take you deeper into the science of what a sustained urban heat event actually does to a city, because I think understanding this will change how you see the numbers I've been giving you. When you combine a massive heat dome with an urban environment, you get what meteorologists call the urban heat island effect interacting with the dome in a way that multiplies the danger. In rural areas outside a major city, the land can release some of its stored thermal energy overnight through radiative cooling, especially if the nights are even marginally cooler. In a dense urban environment, that radiative cooling is severely diminished. Pavement, concrete, brick, asphalt, steel, all of these materials have a high thermal mass. They absorb an enormous amount of solar energy during the day. At night, they radiate that energy back upward in the form of long-wave infrared radiation. Instead of the nighttime air cooling to 65 or 70 degrees the way it might in a rural field, the air in the middle of Philadelphia or Washington sits in an artificial heat bath, created by millions of tons of sun-baked urban material, slowly releasing their stored energy upward. The result is that in the center of a major city during a heat wave with warm overnight lows, the lowest temperature of the entire 24-hour period, the overnight minimum, can be as warm as what a rural area 30 miles away considers its afternoon high. The person sleeping in an apartment in northeast Washington at 2 a.m. is experiencing a temperature that someone in the surrounding countryside might experience at 2 in the afternoon. Without air conditioning in those conditions, the body has no opportunity to reset its core temperature. Sleep quality degrades dramatically. Cognitive function is impaired. And by morning, when the sun rises and daytime heating begins again, the person is starting a new day already at a thermal deficit. Do this for 5 or 6 consecutive days, and the physiological consequences are serious, documented, and well understood by emergency medicine. The heat index values I've been quoting you, 108 in New York, 112 in Philadelphia, 110 in Washington, represent what the human body experiences in terms of perceived heat stress. These are not arbitrary numbers. They are calibrated to physiological response curves. At a heat index of 103, heat cramps and heat exhaustion are possible with prolonged exposure. At 113, heat exhaustion is likely, and heat stroke becomes possible for anyone without active cooling measures. Above 125, which we are not forecast to reach this week, but which some Gulf Coast locations could approach in the most extreme scenarios, heat stroke is imminent for virtually anyone exposed for more than a few minutes. The window between feeling uncomfortable and being in a medical emergency during a heat event is shorter than most people realize. The body's core temperature only needs to rise from its normal 98.6 to 104 degrees to reach the threshold for heat stroke. That is a shift of 5.5 degrees. In humid 95-degree air with a heat index above 110, an unacclimated person doing moderate physical activity can reach that threshold in less than an hour. An elderly person with reduced cardiovascular efficiency and impaired temperature regulation can reach it faster. A young child whose ratio of surface area to body mass is different from an adult and who does not always recognize or communicate that they are overheating can reach it faster still. I want you to remember this when you're thinking about outdoor 4th of July activities, not to discourage you from celebrating, but to calibrate your sense of what the risk actually looks like at ground level. The evening hours on the 4th will not feel dangerous the way a tornado warning feels dangerous. They will feel hot and uncomfortable but manageable. That is precisely when the danger is highest, when the perceived discomfort does not match the actual physiological stress being imposed. I also want to spend some time on the economic and infrastructure dimension of this heat dome, because the consequences extend well beyond human health in ways that affect millions of people this week. Power grids are the first major concern. When temperatures across the eastern half of the country are simultaneously 10 to 14 degrees above normal, residential and commercial air conditioning demand spikes dramatically. The Eastern United States grid operators, PJM Interconnection, which covers the Mid-Atlantic and Midwest, and MISO, which covers the Upper Midwest, have both flagged potential grid stress this week. Peak demand on a typical summer day is manageable. Peak demand when 145 million people are running their air conditioning continuously, overnight as well as during the day, because the overnight temperatures are not providing relief, is a different challenge entirely. The grid operators have been monitoring the situation and utilities in several states have issued conservation requests asking customers to reduce discretionary electricity use during peak afternoon hours to avoid strains on the distribution system. Why does this matter for a heat forecast? Because a power outage during a heat wave of this severity is categorically more dangerous than a power outage during a more moderate weather event. For someone without air conditioning who is relying on a window unit or a portable unit during a 100-degree heat event, losing power is not an inconvenience. It can be life-threatening, particularly for elderly individuals or those with medical conditions. City and state emergency managers in Chicago, Philadelphia, Washington, and New York have all pre-staged resources specifically for this scenario. Cooling buses, mobile cooling units, emergency outreach to vulnerable populations, in part because of the power grid concern. Agricultural and outdoor labour populations are a second major dimension of this event that I want to mention. Farm workers in the Mid-Atlantic and South, construction workers in every affected city, landscapers, delivery drivers, utility workers doing outdoor maintenance, all of these populations face occupational heat exposure that is qualitatively different from what an office worker experiences in the same city during the same heat event. Federal OSHA standards and state regulations require employers to provide water, rest, and shade for outdoor workers when heat index values exceed certain thresholds. Several states in the storm's path have activated worker protection advisories this week. For anyone in an outdoor occupation this week, the standard guidance, frequent water, mandatory rest breaks in shade or cooling environments, early morning scheduling for the most strenuous tasks, is not optional precaution. It is the difference between a difficult work week and a catastrophic one. Transportation infrastructure also responds to extreme heat in ways that most people do not anticipate. Railroad tracks can buckle when ambient air temperatures exceed a certain threshold. The steel expands under heat stress and can bow or kink. Several northeastern rail systems have announced precautionary speed restrictions on certain track segments this week to reduce the risk of rail distortion. Asphalt on roads and airport runways softens. Bridge expansion joints operate at their limits. These are not catastrophic failure scenarios in most cases, but they add to the cumulative stress that extreme heat places on the systems cities depend on. I mention all of this not to add to alarm, but because I think the full scope of what a heat dome of this magnitude actually means for a modern city is underappreciated. The weather is not just uncomfortable. It is actively stressing nearly every system that urban life depends on simultaneously. Health systems, power grids, transportation infrastructure, outdoor industries, and the thousands of small social safety systems that cities rely on to protect their most vulnerable residents. All of those systems are under elevated stress at the same time this week, for the same reason, starting today and running through at minimum Saturday. There is one more dimension of the July and August pattern that I want to bring into this forecast, because I think it is something viewers of this channel will find genuinely useful, and I have not heard it discussed elsewhere with the specificity it deserves. The pattern that develops after the 4th of July weekend, the transition the models are showing in the 2nd and 3rd weeks of July, has a specific character that is important to understand. Rather than a clean shift from heat dominant to storm dominant, the data is showing what I would describe as an oscillating pattern. The jet stream is not going to lock in a fixed position. El Niño's influence on the atmospheric circulation tends to produce a more dynamic and variable pattern during summer, one where high-pressure ridges build and then temporarily relax, where storm tracks shift northward and then southward, where the weeks can alternate between hot and relatively cooler periods within what is still an overall above-normal temperature environment. This oscillating character has two practical implications for this audience. First, it means the severe weather threat is going to be distributed across the whole summer, rather than concentrated into a single outbreak period. If the jet stream is actively moving through the pattern every week, that creates repeated opportunities for organized storm systems to develop and move through populated areas. The northern plains, upper Midwest, and Great Lakes will see repeated rounds of severe weather potential through July and August under this setup. Not one major outbreak followed by a quiet period, but a continuous low-grade threat with occasional significant peaks. Second, the oscillating pattern means that the heat waves of the summer will have ends. The dome will relax, temperatures will drop to or near normal, people will exhale, but those breaks will not mean that the risk is gone. Another dome rebuild is likely to follow within a week or two. For the communities with the most vulnerable populations, this oscillation may actually be more damaging than a single sustained extreme event would be, because the repeated cycle of heat stress and partial recovery, followed by renewed heat stress, is particularly hard on elderly individuals and those with chronic illness. This is one of the more fascinating and concerning aspects of what El Niño does to the summer weather pattern in the United States, and it is a dynamic I am going to be tracking closely and reporting to you throughout the rest of this season. When you look at the 2-week composite picture from the NOAA Climate Prediction Center, the European Ensemble, and the GFS Ensemble mean, all of which I reviewed this morning, the consistent signal is a summer that stays warm and stays active well beyond this specific heat dome event. The atmosphere is not going to give this country a long, stable, below-normal rest period anytime soon. El Niño is building in the Pacific, the Gulf waters are warm, and the jet stream is in a configuration that supports repeated ridge and trough cycling over the central United States for the foreseeable weeks. What that means for this channel is that I am going to be covering a lot of weather this summer, and what it means for you is that this is not the week to decide you do not need to be paying attention anymore once the 4th of July heat passes. The pattern continues, the risks continue, the need for current, accurate, data-driven information continues,